synchronous versus asynchronous code. So let's set up a new project. We'll open up the integrated terminal with Command J or Control J if you're on Windows. We'll run the command, make directory, and we'll name it async demo. Let's change directory into that new folder we created. Now we want to initialize a new Node.js project. We can do that with npm init. Then we'll pass in the flag --yes to accept the defaults. So this created our package.json file. We can clear this out. Now we want to create a new file. We could do this from the command line, and we will run touch index.js. So now, if we expand this directory and click into our index.js file, first we will write synchronous code. So we can add the following console statements. We can do log and then tab for that keyboard shortcut, and we'll log out the string before. So now we'll do shift option and down arrow to copy this line, and then we'll do after. So this code is a simple example of synchronous or blocking programming. So here the program awaits for the first console log statement to execute and to complete before moving on to the second one. We can just output this, node index.js, and we get our expected console log output. So introducing asynchronous programming. In contrast, asynchronous programming allows the program to move on to other tasks before the previous ones have completed. So we will modify our file. Here we will use the setTimeout method. setTimeout. So for the parameter, we will pass in a callback function. So we're using the modern ES6 syntax, our arrow functions. So within this code block, we can, I'll say a comment, simulate a call to the database. So let's say we're making a call to a database that contains information on our grocery list. We can do log, and we'll say reading a grocery item from a database. So for setTimeout, the first argument that we pass in is the callback function. It also accepts a second argument, which is the time to wait before executing this code. This is represented in milliseconds. So we'll say 2000, represent 2 seconds. And let's execute this program. So let's open up the integrated terminal with Command J. Up arrow, and we'll run it again. So here we see before, then after. For our setTimeout, it waits 2 seconds, and then it logs out this console log statement. So this is an example of asynchronous programming. So this demonstrates that setTimeout schedules the task to be performed later without blocking the execution of subsequent code. Understanding asynchronous programming. Asynchronous programming is not the same as concurrent or multi-threaded programming. In Node.js, asynchronous code runs on a single thread. It's crucial because operations involving disk or network access in Node.js are handled asynchronously, allowing the program to remain responsive. Asynchronous programming helps ensure that your application can handle multiple operations efficiently, without getting stuck waiting for one task to complete before starting another. How does asynchronous programming improve the efficiency and responsiveness of a Node.js application, especially in handling I/O operations? Asynchronous programming improves the efficiency and responsiveness of a Node.js application by allowing the program to continue executing other tasks while waiting for I/O operations, such as a database call or file access, to complete. This non-blocking approach ensures that the application remains responsive and can handle multiple operations simultaneously, rather than being held up by slow operations. As a result, the application can serve more users and manage more tasks without delays or bottlenecks, leading to better performance overall. What are the key differences between synchronous and asynchronous programming in the context of Node.js, and why is it important for developers to understand these differences? Synchronous programming in Node.js executes tasks one after the other, blocking the execution of subsequent code until the current task is finished. Asynchronous programming, on the other hand, allows the program to initiate tasks, like I/O operations, and move on to other tasks without waiting for the previous ones to complete. Understanding these differences is crucial because asynchronous programming helps prevent bottlenecks, making applications more efficient and responsive by not allowing a single slow operation to halt the entire program. So let's discuss patterns for dealing with asynchronous code. Let's first go over an example of incorrect synchronous code. So we'll build upon the previous code snippet that we did in our previous lesson. So we have our console log statement outputting before, and then we call setTimeout. So let's abstract this and let's put this into a function. So we use the function declaration syntax, and we'll name it getGroceryItem, and it takes in an ID, our curly braces. And let's move this, so we'll copy this, and we can paste it in the block. So rather than just console logging, we will return a JavaScript object which contains an ID and a name. So we'll say apples is the name of the grocery item, end it with a semicolon. So now let's call this function. I can say const grocery item, say get grocery item, and we'll pass in the value of 1 as the ID. Let me just add a comment here so we know what to expect. So we cannot get the grocery item like this, as we will see. Then let's do console log. We will output the grocery item. So note that when we do this, this will have the value of undefined. The reason is because when we call getGroceryItem, the item isn't returned immediately. Because we call setTimeout, there's a 2-second delay before we get this grocery item object. Let's open up the integrated terminal, up arrow, and we will execute this file. So here we get before, undefined, then we get this output, after, and then this console log statement within the setTimeout. So this function, getGroceryItem, is intended to simulate fetching an item from a database. However, due to the setTimeout function, it does not return the grocery item immediately. Instead, it schedules the operation to occur after 2 seconds. So the console log and then the grocery item executes before the grocery item data is available, resulting in undefined. The key reason this does not work as intended is because setTimeout is asynchronous. The function does not wait for 2 seconds to return the grocery item data, rather it returns immediately and the code continues executing. So let's correct this approach. When dealing with asynchronous operations like database calls, the result is not immediately available. Here are 3 common patterns to handle asynchronous code in JavaScript. The first being callbacks, the second being promises, and the third being Async and Await. So first let's discuss using callbacks. So we will fix our code to utilize that pattern. So we have our console log statement. Actually, let's comment this out and we will start again from scratch. So here, we can do console.log, output the string before. Then we can implement getGroceryItem. This takes in an ID, and it will accept a second parameter, which is a callback function. We can call setTimeout, and this also accepts callback function with a 2-second delay. So within it, let's output, I'll say, reading a grocery item from a database, and we'll say callback. Then we'll pass in the object, right? The grocery item object, the ID, and then the name, which we will say is Apple. And that with a semicolon. So we want to utilize the getGroceryItem function. In its implementation, it is using the asynchronous method of setTimeout. So we can call getGroceryItem, pass in 1 as the ID, and then for the callback, we specify an ES6 arrow function. Right, so we're using the modern syntax, grocery item, arrow, and then the curly braces. And here we will define our implementation. And here we will just output the grocery item that is returned. Right, so this object is passed into the callback. And so this object will be the grocery item that we are outputting to the console. And then one more log, which is the string after. So now we will execute this, up arrow. So we can run this. So we get before and after. Then it waits 2 seconds. And then we see reading a grocery item from a database, and then our expected grocery item object. If I scroll up, previously when we had our synchronous code, we were outputting the grocery item and getting the value of undefined. So this is a pattern known as callbacks. So I'll just add a comment here and I'll say callbacks. And for now, I will comment it out and paste it. So now we will update this and it will use promises. So we have our console log statement saying before, and then we have the getGroceryItem function. So rather than calling setTimeout as this, we can utilize a promise object. So a promise is an object that holds the eventual result of an asynchronous operation. So we can use the return keyword, and I'll say new promise. This accepts two parameters. So resolve in the case when it works successfully, and reject in the case when there was an error. So this is an arrow function, right? So a callback. We will explore each of these concepts in more depth throughout this section. Just wanted to introduce it to you all at once. So we moved up the setTimeout to be within the callback function. Now we can remove callback. And rather than saying callback, we say resolve, because it successfully returns a grocery item. So now we have to change how we're utilizing this. So we only need to pass in the ID, but we have special methods in order to access the data within the promise. So we use a special method, which is then, which is executed in the case when the promise successfully resolves. So we'll take in the item, and we will console log it. And we also need a method .catch. Let's end this with a parenthesis. In the case when there is an error. So if there is an error, in the case when it is rejected, then this code will run. So I'll say console.error, and then the error. And that with semicolon. So now, open up our integrated terminal. We'll run this, so we see before, after. And once again, this waits for 2 seconds. Then it returns a promise. So we can access the data within that promise with the .then method. And then we output it to the console. All right, so we'll explore this more in detail in future lessons. For now, let's just add a comment. I'll say promise. Let's copy this, and we'll build upon it for our next example. We'll comment it out for now. Now we will cover async await. So async await are special keywords that allow us to execute this code with cleaner syntax. So here we are using the .then and .catch methods and chaining them in order to access the data that is returned from our promise. So we'll keep our getGroceryItem function to be the same, but we can have different syntax to make this cleaner to read. So I can use a special keyword known as async, which means that this function contains an asynchronous operation. So I'll name the function display grocery item. So we will say grocery item. Then we'll use another keyword, await, and then we will specify our function, which has the asynchronous operation. So in this case, the setTimeout function. Then we can simply log it out. Grocery item. So rather than using this syntax and chaining the .then and .catch methods, we can just call display grocery item and pass in the ID of 1. Open up our integrated terminal, run it again. So we see, once again, before and after. And once this asynchronous operation completes after 2 seconds, then we successfully log it to the console. So let's do a quick summary. First, we covered callbacks. So these are functions passed as arguments to be executed once an asynchronous operation is complete. We covered promises, which are objects representing the eventual completion or failure of an asynchronous operation. And lastly, we covered async await. So this is syntactic sugar over promises, making asynchronous code look synchronous. Understanding these patterns is crucial for handling asynchronous operations, such as database calls in JavaScript. What are the main methods for handling asynchronous operations in JavaScript, and why is it important to understand them? The main methods for handling asynchronous operations in JavaScript are callbacks, promises, and async await. Callbacks involve passing a function to be executed after an asynchronous operation completes. Promises represent the eventual completion or failure of an asynchronous task and provides methods like .then and .catch for handling results. Async await is built on promises, allowing asynchronous code to be written in a more readable, synchronous-like style. Understanding these methods is crucial for managing tasks like database calls, ensuring efficient and correct code execution. How does the asynchronous nature of JavaScript impact the execution order of code, and what are the strategies to manage this effectively? The asynchronous nature of JavaScript means that code doesn't always execute in the order it's written. Some tasks, like I/O operations, run in the background while the rest of the code continues. This can lead to unexpected results if not managed properly. To handle this, developers use strategies like callbacks, promises, and async await to control the flow of asynchronous operations, ensuring that tasks complete in the desired order and their results are handled correctly. So let's discuss callbacks in more detail. First, if you look over our example of the incorrect synchronous code, where we call a function getGroceryItem, which is utilizing setTimeout with a 2-second delay. When we output it, we get the value undefined because the value is not immediately available. So this code mimics trying to get a grocery item from a database, but it doesn't work as intended because the function getGroceryItem uses setTimeout, making it asynchronous. So the console log statement executes before the grocery list data is available, resulting in undefined. A callback is a function that is passed as an argument to another function, to be executed once an asynchronous operation is complete. So let's go over using callbacks correctly. So we have our updated version of the code, which utilizes callbacks. So we have our callback parameter, and then we invoke it within the asynchronous operation. So let's discuss accessing nested asynchronous data. So to handle multiple asynchronous operations, such as fetching a user's grocery list and then fetching the grocery item data, you can nest callbacks. So here, when we call getGroceryItem, we're currently just outputting it. So let's say we're calling getGroceryList. This takes in an ID, and then a parameter, which is a callback function. This is an asynchronous operation, so we'll mimic that with the setTimeout function. Pass in our arrow function, which has a 2-second delay. I'll add a comment and I'll say simulate a call to the database log, and I'll say fetching grocery lists from the database, and then we'll utilize our callback and we'll pass in the argument, which is a JavaScript object representing the grocery list. So it's a property of items, which takes in an array. So we'll say apple, bananas, and we'll say bread. So we can end that with a semicolon. Let's update our getGroceryItem. So I can say, I'll say fetching grocery item from, I'll say the grocery list, just to better describe what we're trying to implement here. So I'll say callback, and we'll say the array is apples, bananas, and bread. So now we want to utilize getGroceryList. So rather than calling getGroceryItem, we'll say getGroceryList. This accepts an ID, so we'll say 1, and then our callback function. So it'll be a grocery list. We'll pass in an arrow function. So I'll log, and I'll output grocery list, comma, grocery list. So now I will simulate getting the grocery list items, and I'll say get grocery list items, grocery list ID, and then a callback function containing the items. And we can output that with items, and then outputting that to the console. And we'll end it with a semicolon. So this is an example of nested callbacks, meaning that you have one asynchronous operation, And once that completes and we have the data that we need, then we make another asynchronous call utilizing that data. So let's comment this out, save it, and then in our integrated terminal, up arrow, and then run. So we get before and then after. Then we get fetching the grocery list, and then the data that we received. And then we call our nested callback function here. So fetching a grocery item, and we get the items. So this demonstrates utilizing nested callback functions. So in summary, callbacks are functions passed as arguments to be executed once an asynchronous operation is complete. Properly handling asynchronous code is crucial when dealing with operations like database access, which may take some time to complete. Why is it important to handle asynchronous operations properly in JavaScript, particularly when dealing with tasks like database access? Handling asynchronous operations properly in JavaScript is crucial because it ensures that tasks like database access, which may take time to complete, do not block the execution of other code. This allows your application to remain responsive, efficiently processing multiple tasks without waiting for each one to finish sequentially. Proper management of asynchronous operations, such as using callbacks, promises, or async await, prevents issues like incomplete data retrieval or unexpected behavior, ensuring that the application functions correctly and smoothly. What challenges can arise when using callbacks to manage multiple asynchronous operations, and how can these be effectively addressed? When using callbacks to manage multiple asynchronous operations, challenges like Callback Hell can arise, where nested callbacks make the code difficult to read and maintain. This complexity increases the risk of errors and makes debugging harder. To address these issues, developers can use techniques such as modularizing callback functions, or better yet, use promises or async await syntax, which allows for more readable and maintainable code by flattening the structure and handling errors more effectively. So let's further discuss nested callback structure. In our previous example, we used callbacks to handle asynchronous operations. So we will expand upon this and we will add another asynchronous operation. So we can add that with, I'll name it check item availability. This will accept one parameter, which is the grocery item, and this utilizes the asynchronous method of setTimeout, pass in our callback, and I'll say checking availability. Then we can say return true, just for simplicity. So if we want to utilize it, we need to do so within the getGroceryItem callback, because we are dependent on that data. So this takes in, we can say items at the 0th index, so the first item. Let's clean this up a bit. So we can clear this. And just so we can more easily see our nested callbacks, we'll remove the outer console log statements. So here we see we have getGroceryList, which is an asynchronous operation. Once that completes, then we call getGroceryItem, which is also asynchronous, and then the asynchronous method checkItemAvailability. So this is simulating making calls to a backend database or a backend API. So in this scenario, each callback depends on the completion of the previous one, resulting in a nested structure. This pattern is often referred to as Callback Hell or the Christmas tree problem because of its shape and complexity. So let's compare this to synchronous code. So just as a demonstration of what this would look like if all functions were synchronous, right? So it would have the log statement, same before, and then getting the list, so it's getGroceryList, takes in the ID of the grocery list, and then we get the items of the grocery list, calling getGroceryListItems, say list ID. Then we'll check the availability of an item, check item availability, and we'll say the first item in the list. Then we'll output, so log and tab after. So this is an example of how clean and easy to read our code would be if it were synchronous. However, we know that these functions are asynchronous, so the data isn't available immediately. There's a delay before we can receive that. All right, let me just add in the 2-second delay to our callback function, which I forgot to do. So, however, synchronous code blocks the execution of other operations until the current one finishes, which is not ideal for IO-bound tasks like database queries. So let's discuss the term of Callback Hell. We scroll back up. So using callbacks for asynchronous code can become difficult to manage and read. Here we see our nested structure. So let's discuss a simple solution. To avoid Callback Hell, we can use promises and async await syntax. So let's discuss using promises. Promises provide a cleaner way to handle asynchronous operations. So here's an example. For now, we will comment how we are utilizing our asynchronous functions. And rather than calling setTimeout, rather we will return a promise. Right? Once again, a promise is an object that holds the eventual result of an asynchronous operation. So we'll say return new promise, and within it, it accepts a callback. So we'll say resolve. For now, we will close that, and we can move this up. We can move it up with Option up arrow. Close this. So rather than saying callback, we can remove that parameter. It's no longer needed. And rather we call resolve, because it resolved or completed successfully. We updated this one to use promises. Let's update the other functions. Return new promise. This also accepts callback function with resolve. So this here. Once again, Option up arrow. And within here, let's do command and then the right bracket. Better format this code. And we'll do the same here. So it looks cleaner. So once again, we remove this callback. It's no longer needed. And we call resolve. It successfully returns the grocery items. Now we have our last one. We have check availability. So once again, return new promise. Takes in callback function with resolve. Then Option up arrow to move it up. In this case, it just returns the value true. So in this case, we can just say resolve. We'll just say the value of true. So now we want to utilize this. So for now, we can delete this example we had of synchronous code and just to demonstrate what we would like the syntax to look like. Let's make some space here. And now we will utilize these functions that are utilizing promises. So we can call get grocery list, takes in the value 1, then get the list, and we call get grocery items, takes in the list ID. Then we can chain .then, right? So the result of get grocery list item or get grocery item. So get the items, and we'll say check item availability, items at 0. And we'll just say .then, and we'll say availability, console.log, availability, and then this value. We'll also include our method, or chain our method for catch, in case there's any error, console.log. Actually, we'll do console.error, and then the error. So this is an example of utilizing promises. So we use the .then method and .catch methods. So we were, rather than having the nested structure, we just chain our .then methods. We can execute this, so up arrow and run, before and after, and there are 2-second delays as the asynchronous operations complete. So everything worked as expected, and we have cleaner syntax. So let's discuss using async await. So the async await syntax, built on top of promises, further simplifies the code. So currently, it's in get grocery list. We are returning a promise. But let's say if we're using the async await keywords, so we can mark it as async. And when we mark it as async, we can now utilize the await function within it. So rather than calling get grocery list and then chaining all these methods, we'll create a new method, and we can name it display availability. we will mark it as async. So once we mark it, then we will utilize the await keyword within it. We will wrap it in a try catch. Console.error. And now we want to utilize these asynchronous operations. So because these are asynchronous and they're returning a promise, we can use the await keyword. So we'll say list, await, get grocery list, pass in the ID. Then, once this data is available, then we can call await, get grocery item with the list ID. Right, so once this returns, right, we await this result. Then we check the availability. Await, check item availability, items at 0. And then say console.log availability, and then this result. So rather than utilizing this syntax, comment this out, and we'll just call display availability. So this function, which utilizes the async await keywords, is the equivalent of this function call with the chained methods. But our code here, which utilizes async await, looks more similar to synchronous code, so it's easier to read. So let's run this. So we see before and after, 2-second delay, and we get our expected result with cleaner syntax. So this is the modern way to do it, with async await. So in summary, callbacks can lead to nested structures that are difficult to manage. Promises and async await provide cleaner, more readable ways to handle asynchronous code. What are the benefits of using promises and async await over callbacks in managing asynchronous operations in JavaScript? Using promises and async await in JavaScript offers several benefits over callbacks. The first being readability. Promises and async await result in cleaner, more linear code that is easier to read and maintain, avoiding the nested structure of callbacks, otherwise known as Callback Hell. The second benefit is error handling. Promises provide better error handling through the .catch method and try-catch blocks with the async await keywords, making it easier to manage asynchronous errors. The third benefit is control flow. Promises and async await allow for a more intuitive control flow, helping developers manage asynchronous operations more effectively. How does the use of promises and async await help prevent issues like callback hell in JavaScript programming? The use of promises and async await in JavaScript helps prevent callback hell by making asynchronous code more linear and easier to follow. Promises allow chaining of asynchronous operations with the .then method instead of deeply nested callbacks, while async await further simplifies the syntax, making the code look and behave more like synchronous code. This reduces complexity, improves readability, and makes error handling more straightforward, resulting in cleaner and more maintainable code. So now let's discuss name functions. So we use name functions to simplify callbacks. When dealing with nested callbacks, you can replace anonymous functions with name functions to flatten and simplify the structure of your code. This approach makes your code more readable and easier to manage. So here's how you can refactor nested callbacks using name functions. So implement this from scratch just to ensure that everything makes sense, and it's good to get more practice. So once again, we have our log statement, say before, and then shift option down arrow, after. Now we'll implement our functions again. Get grocery list, takes in an ID, and a callback. So that's the 2 parameter variables it accepts. Then set timeout, which is an asynchronous operation. The argument takes in is a callback function. And here we are, simulating a call to the database. We can log that out. So I'll log out fetching grocery list from the database. Once again, this calls the callback and invokes it, pass in the object, which is an ID, and a name, we'll just say that's weekly groceries, and that with a semicolon, and there is a 2-second delay. So now, to help us save some time, we can just copy this and paste it, and we'll rename it to be get grocery items. So for our console log, we'll say fetching grocery items. So for our callback, this accepts an array, and we'll just say milk, bread, and eggs as the data that we pass in. Once again, we can copy this and paste it, and we'll name this to be check item availability. So we'll update our console log statement, which will be checking item availability. So for our callback, we'll pass in a JavaScript object, which will contain the item and the availability. So I'll say available, set to true. So now we implemented 3 asynchronous operations, each which have a 2-second delay. Now in order to actually utilize this, we want to have name functions. So let's implement some functions here. And I'll call this handle grocery items. This takes in a list. And I'll call get grocery items, the list ID, and handle item availability. So now implement takes in the items, and within it this calls check item availability. So I'll say the first item, and then I'll pass in callback, so display availability. So now we need to implement that name function. This takes in the availability. This outputs to the console. Availability. Pasting that here. So now I can call get grocery list. The ID will be 1. And then for the callback, I'll say handle grocery items. So that will call this function, which will call get grocery items. And then for the callback is handle item availability. Then this calls check item availability. And then after, within it, the display availability is called, logging to the console. We can execute this. Go forward and after. Then we get our 2-second delays and our expected console outputs. So here we see item is not defined. Let's see here in checking item availability. Yeah, so for ID, it's supposed to be item. Run it again. Now we get our expected output. We just need to change the name of that parameter. So explanation. Let's first discuss name functions. By defining name functions, let's scroll up. By defining name functions like handle grocery items, handle item availability, and display availability, you can avoid deep nesting and improve the readability of your code. Let's discuss passing references. Note that we are passing references to these functions. So this includes handle grocery items, handle item availability, and display availability, instead of calling them directly. So what are the advantages? The first is readability. The code is easier to read and understand. The second advantage is reusability. Name functions can be reused elsewhere in the code if needed. Limitations. While using name functions helps, it's not the most efficient way to handle asynchronous code. For a better approach, consider using promises. So using promises. Promises provide a cleaner, more manageable way to handle asynchronous operations compared to nested callbacks. So here's how you can convert the above example to use promises. So here, for each of these functions that we implemented, we want to call return new promise. This object takes in the callback, so resolve. And we just move this up, option up arrow. And then instead of callback, we just call resolve. We can remove the callback parameter. We just repeat this, so return new promise, takes in and resolve. Move that up, option up arrow. Save that. And one last time. Oh yeah, we have to remove the callback parameter and then call resolve. Then last time, we get return new promise, takes in, resolve, and we move this up and save that, and we call resolve here. Now in order to utilize that, we will no longer be calling or invoking it like that. Rather, we will call get grocery list, passing in the ID of 1, and then we have our methods .then and .catch. So we chain these methods, list. So I know we did cover this before, but repetition is very good, especially if this is the first time that you are going over promises. So .then, items, and we'll call check item availability, which is the first item in the list. Then, say availability, console.log, availability, and then this parameter variable. And then we end it with .catch. So we'll pass in the error that one occurs, console.error, and then the error. End it with a semicolon. So now we execute this code, which is utilizing promises as opposed to callback functions. So we have before and after, and then 2-second delays for our expected console output. Now we get cleaner syntax without having to pass all of these references to all these functions we created. So using promises makes the code more straightforward and easier to handle, especially as the complexity of asynchronous operations increases. How can refactoring nested callbacks into name functions improve the readability and maintainability of asynchronous code in JavaScript? Refactoring nested callbacks into name functions improves the readability and maintainability of asynchronous code by reducing complexity and avoiding deeply nested structures, known as Callback Hell. Name functions makes the code more organized, easier to follow, and allows for better reuse of code. This approach simplifies debugging and understanding the flow of asynchronous operations, making it easier to manage and maintain the codebase as the application grows in complexity. What are the limitations of using name functions for handling asynchronous operations, and how do promises provide a more efficient solution? The limitations of using name functions for handling asynchronous operations include increased complexity when dealing with multiple asynchronous tasks and a tendency to create deeply nested structures. While name functions improve readability, they don't fully resolve the issue of callback hell. Promises provide a more efficient solution by allowing for a more linear and manageable flow of asynchronous tasks through chaining, which improves readability and simplifies error handling, leading to cleaner and more maintainable code. So let's discuss promises. JavaScript promises are a powerful tool for managing asynchronous operations. A promise is an object that represents the eventual result of an asynchronous operation. It can be in one of three states. The first being pending. So this is the initial state when the promise is still waiting for the asynchronous operation to complete. The second state is fulfilled. The operation completed successfully and the promise has a value. And the third possible state is rejected. So the operation failed and the promise has an error. So creating a promise. To create a promise, you can use the promise constructor, which takes a function with two parameters, resolve and reject, and these parameters are functions used to indicate the completion of the asynchronous operation, either successfully, which would be the case when it resolves, or unsuccessfully, in the case when it rejects. So to demonstrate this, say const p, and then new promise. This takes in a callback, so resolve and reject. It's our arrow function syntax. Then we can start an asynchronous operation, such as accessing a database or calling a web service. So if the operation is successful, then we call resolve with the result. If the operation fails, then we call reject with an error. So in the first case, we'll say resolve to demonstrate an example of a successful operation. So the output, value of p, and we run this. We get the promise with the value of 1, better yet, dot then. So we'll say result, console.log, the result, and we'll just chain these methods actually. So dot catch, error, console.error, passing in that error object. So we'll run this again, and we get the value of 1, which is the value that was passed in when we resolved this promise. Likewise, if we were to call reject, we'll pass in an error, so I can say new error, and I'll say error message. In the case of a failed operation, we execute this, and we get our expected error message. So let's discuss consuming a promise. So once you have a promise, you can use the .then and .catch methods, as we did, to handle the result or the error. Let's go over an example of handling errors. So we'll update this example to simulate an asynchronous operation that failed. So we can call setTimeout, pass in, callback, and we'll say it has a 2-second delay. Let's move this up, so option and up arrow. So now, when we do this, let's update this to be console.log, and we will log out the message of the error. Right, so in this case, it would be error message. So now, when we run this in our integrated terminal, so Command J, up arrow and run, there's a 2-second delay, and then we get the error message. So in summary, a promise starts in the pending state. It transitions to fulfilled if the asynchronous operation completes successfully. It transitions to rejected if the operation fails. We use the .then method to handle the successful result, and we use the catch method to handle errors. Finally, let's discuss best practices. Whenever you have an asynchronous function that takes a callback, consider modifying it to return a promise for better readability and maintainability. This approach helps avoid callback hell and makes the code easier to follow. How do promises improve the management of asynchronous operations in JavaScript, particularly compared to traditional callback methods? Promises improve the management of asynchronous operations in JavaScript by providing a more structured and readable way to handle tasks compared to traditional callbacks. They allow you to chain operations like .then for success and .catch for errors, handling callback hell, and making the code easier to follow. Promises also offer better error handling and simplify the process of managing multiple asynchronous operations, leading to cleaner and more maintainable code. Why is it beneficial to modify asynchronous operations that use callbacks to return promises instead, and how does this practice enhance code readability and maintainability? Modifying asynchronous functions to return promises instead of using callbacks is beneficial because it simplifies the code structure, making it more readable and easier to maintain. Promises allow for chaining operations and handling errors more cleanly with .then and .catch methods, reducing the complexity associated with nested callbacks, known as Callback Hell. This approach leads to more organized and modular code, which is easier to debug and scale as your application grows. So let's discuss resolving callback hell by using promises. So in this code that we wrote in a previous lesson, This demonstrates nested callbacks, also known as Callback Hell, which can make your code difficult to read and maintain. So here in this case, we have 3 asynchronous methods, and they depend on each other. So these run one after another. Now you can imagine if we had to perform other asynchronous operations, then we would continue to have to indent and continue to nest these callbacks. So this video is just a reminder that we want to utilize promises when working with asynchronous code. We do this to improve the readability and maintainability of our code base. So in this case, instead of utilizing callbacks, we are returning a promise. Right, once again, a promise is an object that holds the eventual result of an asynchronous operation. And then we can utilize the built-in methods, so .then and .catch, to chain these methods and work with the asynchronous data. This approach makes the code more linear and easier to read, eliminating the deep nesting associated with Callback Hell. So in summary, promises, these are objects representing the eventual completion or failure of an asynchronous operation. Now, these promises can be in different states. So promises can be in one of 3 states. So it could be pending, fulfilled, or rejected. So methods that promises have include the .then method to handle resolve values and .catch to handle errors. And lastly, converting callback-based functions to return promises can significantly improve code readability and maintainability. How do promises help in resolving the challenges of Callback Hell in asynchronous JavaScript programming? Promises help resolve the challenges of Callback Hell in asynchronous JavaScript programming by allowing you to chain asynchronous operations in a more linear and readable manner. Instead of deeply nesting callbacks, promises use .then and .catch methods to handle success and errors, respectively. This flattens the code structure, making it easier to understand, maintain, and debug. By converting callback-based functions to return promises, developers can write cleaner, more manageable code while avoiding the complexity and pitfalls of nested callbacks. What are the key benefits of converting callback-based functions to return promises, particularly in terms of code readability and maintainability? Converting callback-based functions to return promises offers key benefits in terms of code readability and maintainability. Promises allow for chaining operations using .then and .catch, which results in a flatter, more linear code structure, making it easier to read and understand. This approach eliminates the deeply nested, hard-to-manage code typical of callbacks known as Callback Hell. Additionally, promises provide a consistent way to handle errors, further enhancing the maintainability of the codebase. So let's go over creating subtle promises. Sometimes you might need to create a promise that is already resolved. This can be particularly useful for unit testing, where you need to simulate a successful asynchronous operation, such as a web service call. To create a resolve promise, you can use the promise.resolve method, which returns a promise that is already resolved. So we can create a new file here. From the command line, I'll say touch promise API.js. So we can go into this new file that we created, and then we can call const p assigned to promise.resolve. We'll pass in an object, so in this case, it will have a property of ID, the value of 1, and then to access this value, we use the .then method, and we pass in a callback, so we'll get the result, and we'll just output that. Right, outputting the result, open up the integrated terminal with Command J or Control J, and then we will run node promise API.js, and here we get the expected resolve value. So this code snippet creates a resolve promise with an object containing an ID of 1 and logs the result to the console. Now let's go over creating rejected promises. Similarly, you might need to create a promise that is already rejected. For instance, to simulate a failed asynchronous operation in a unit test. You can use the promise.reject method to create a rejected promise. So we can close this out, so Command J, and we'll update this to instead use reject, and then for the argument, we pass in a new error object. So new error, and then the message will be reason for rejection, and 3 dots. So now, there's p.then, We can call .catch. In this case, we can do error, console.log, and I can say error.message. So because we are expecting an error, or the rejection rather, we'll just include the .catch method, right? So remove the .then method. So let's run this. And we're expecting the error message, reason for rejection. Say for rejection. So this creates a rejected promise with an error message, and we log the error to the console. So in summary, resolve promises use the promise.resolve and then pass in the value to create a promise that is already resolved. And for rejected promises, use promise.reject and pass in an error object to create a promise that is already rejected. These methods are useful for simulating different scenarios in unit tests or when you need immediate resolution or rejection of promises. These methods are useful for simulating different scenarios in unit tests or when you need immediate resolution or rejection of promises. How can creating resolved and rejected promises with methods like promise.resolve and promise.reject be useful in testing and simulating asynchronous operations? Creating resolved and rejected promises with methods like promise.resolve and promise.reject is useful in testing and simulating asynchronous operations because they allow developers to immediately generate success or failure outcomes without needing to perform actual asynchronous tasks. This capability is particularly valuable in unit testing, where you may want to test how your code handles resolved or rejected promises, such as simulating successful API responses or error conditions, ensuring your code behaves correctly in different scenarios. So let's discuss running multiple asynchronous operations in parallel. Sometimes you need to run several asynchronous operations simultaneously and perform an action once all of them have completed. For example, you might call different APIs like Facebook and Twitter, or X, and once both calls finish, you return the result to the client. Let's go over an example of this. So we'll have a simulation. I'll say simulation for calling Facebook API. So I'll say const, and I'll say P1 for the first promise, new promise. So we know this takes in a callback, takes resolve as the first parameter, and within it we'll have set timeout as our asynchronous operation. This also takes a callback. And we'll say the delay is 2 seconds, right? So 2000 milliseconds. Then we will log. I'll say async operation, 3 dots, and then resolve with the value of 1. And then we'll have a simulation for calling the Twitter or X API. So we can actually just copy this because it'll be the same syntax. Just need to change it to be P2 to represent the second promise. I'll say async operation 2. And I'll say async operation 1 just so we can differentiate these console log statements. So now I'll say running both asynchronous operations. Let's scroll up so we can see it better. I can say promise.all, and then I'll pass in an array containing both of these promises, so P1 and P2. Now I'll call .then, takes in the result, and I will console log the result. And I'll also do .catch. Wait, let me remove the semicolon. So this takes in an error, console.log, and I'll say error, error.message. Now we can end that with the semicolon. So this code kicks off 2 asynchronous operations and uses promise.all to wait until both promises are resolved. The then method is called with the results when both operations complete. So let's execute this. So Command J or Control J, and then node index.js. So once both of them are completed, then we see async operation 1, async operations 2, and then you see the 2 values that they return, that they resolve to. We update this to be 2. We'll run it again. So once again, we get the expected output. So now let's discuss handling promise rejections. If one of the promises fail, then promise.all will reject and the catch method will handle the error. So if any one of them reject, then the .catch method will be executed. So you can say, for example, rather than this being resolve, we'll specify the second parameter of reject, and we will invoke that. So this operation failed. We can run that. So here we see the error with the value of undefined. So rather than passing 1, let's pass in a new error, and I'll say async operation 1 failed, right, for a descriptive error message, rather than just the value 1. Now we got our expected error message. So in this example, if P1, right, the first promise, right, the simulation for calling the Facebook API, if that fails, then the entire promise.all will reject, and the error will be logged. So now let's discuss using promise.race. If you need to proceed as soon as possible as one of the promises is fulfilled or rejected, you can use promise.race. So rather than promise.all, we can do promise.race. And in this case, with promise.race, the first promise to resolve or reject will determine the outcome. If it resolves first, the then method will be called with the result of the first fulfilled promise. If it rejects first, the catch method will handle the error. So we can see an example of this. Let's run it again. So in this case, the P1 rejected before the second operation. Likewise, let's say if I do comment this out, and if I say resolve with the value of 1, so once again, promise.race will resolve or reject based on the first outcome. So here we see for the result was the value of 1, as the async operation 1 completed first. So in summary, with promise.all, this waits for all promises to resolve. If any promise rejects, the entire promise is rejected. With promise.race, this resolves or rejects as soon as one promise resolves or rejects. These methods help manage multiple asynchronous operations effectively, ensuring that your code is cleaner and more maintainable. What are the advantages of using promise.all and promise.race for handling multiple asynchronous operations in JavaScript? Promise.all allows you to run multiple asynchronous operations in parallel and waits for all of them to complete before proceeding. It's useful when you need all tasks to finish successfully before taking the next step. If any promise fails, the entire operation fails. So with promise.race, it resolves or rejects as soon as one of the promises completes, making it useful when you want to proceed based on whichever task finishes first. This approach can help optimize performance when only the quickest result is needed. How can managing multiple asynchronous operations with promises enhance the efficiency and readability of JavaScript applications? Managing multiple asynchronous operations with promises enhances the efficiency and reliability of JavaScript applications by allowing tasks to run concurrently, reducing wait times. With promise.all, this ensures that all tasks complete successfully before proceeding, making the application reliable when multiple results are needed. With promise.race, this allows the application to respond faster by acting on the first completed task, improving performance in scenarios where the quickest result is prioritized. These tools help structure and control complex asynchronous workflows, leading to cleaner, more maintainable code. So let's go over simplifying our asynchronous code with the async await keywords. JavaScript's async and await features provide a more readable and straightforward way to write asynchronous code resembling synchronous code. So here's an example using promises that we did in a previous lesson. So here we see we have 3 functions which use an asynchronous operation. So each of them are using setTimeout, and each of them return a promise. So to utilize these and to get access to the result of the synchronous operation, we use the .then methods in order to access the data, and we chain the methods. Now we could also implement this using the async await keywords. So rather than doing it like this, I can implement a function, and I'll use the async keyword. We can name this display item availability. So we can say const list Now we use the await keyword to await the result of the asynchronous operation. So we call get grocery list. We'll pass in the ID of 1. Then we'll get the items. Say await get grocery items. We'll say list.name. See? Yep. So the name of the list. Then we'll get the availability. The await keyword, check item availability. So the first item in the list. And then we'll output availability. And then we output the result of that. So now, let's comment this out for now. And we'll just invoke this method. So now if we were to execute this file, need to change it to the correct directory. That would be 9. I can run. So here I get the output of after, then fetching grocery list from the database, fetching the grocery items, and then the availability of the item. So an explanation of this code, we use the await keyword. So this keyword allows you to wait for a promise to resolve and get its result. You could use it only inside functions marked with the async keyword. So let's discuss async. This keyword is used to declare that a function is asynchronous. It ensures that the function returns a promise. When using await, the JavaScript engine pauses the execution of the function until the promise settles. This makes the asynchronous code look like synchronous code, which is easier to read and understand. So handling errors with async await, in the promise-based approach, the .catch method is used to handle errors. And with async await, you use a try-catch block. So once again, we update this. So I'll say try. Let's highlight all this, and we'll do option up arrow to move it up. Then we can say catch error, and then we can log this error out. So that would be error, do colon, error.message. Better format this, and then we save it. So in summary, async and await provides a cleaner way to write asynchronous code that looks like synchronous code. For error handling, we use try and catch blocks to handle errors when using async and await. Using async and await can make your asynchronous JavaScript code much more readable and easier to maintain. This syntactic sugar over promises simplifies the code structure significantly. How do the async and await keywords simplify the process of writing and understanding asynchronous code in JavaScript? The async and await keywords simplify writing asynchronous code in JavaScript by making it look and behave like synchronous code. Async marks the function as asynchronous, automatically returning a promise, while await pauses the function's execution until the promise resolves. This eliminates the need for complex promise chains and nesting, resulting in more readable, maintainable, and easier to understand code, especially when dealing with multiple asynchronous operations. What are the benefits of using async and await for error handling in asynchronous JavaScript code compared to traditional promise-based methods? Using async and await for error handling in JavaScript provides a more straightforward and readable approach compared to traditional promise-based methods. With async and await, you can handle errors using try and catch blocks, which are familiar with synchronous code, making it easier to understand and manage. This approach avoids the need for chaining catch methods, resulting in cleaner code that is easier to debug and maintain, especially in complex asynchronous workflows. So let's summarize what we covered in this section. So this section was about synchronous versus asynchronous code. Understanding the difference between synchronous and asynchronous code is fundamental in JavaScript. Synchronous code executes sequentially, blocking further execution until the current task is completed. In contrast, asynchronous code allows other operations to continue while waiting for an asynchronous task to complete, improving performance and responsiveness. Let's go over the patterns for dealing with asynchronous code. JavaScript offers several patterns to manage asynchronous operations, the first being callbacks. These are functions passed as arguments to other functions to be invoked once an asynchronous operation is complete. The second pattern is promises. These are objects representing the eventual completion or failure of an asynchronous operation. providing a cleaner way to handle asynchronous logic. The third pattern is Async and Await. This is syntax that makes asynchronous code appear synchronous, enhancing readability. Let's go over callbacks. Callbacks were the original method for handling asynchronous code in JavaScript. They involve passing a function to another function to be executed after an operation completes. So let's talk about the concept of Callback Hell. These are nested callbacks, which can lead to Callback Hell, which is a situation where code becomes deeply nested and difficult to manage. This pattern complicates both reading and maintaining the code. Named functions. To mitigate Callback Hell, named functions can be used to flatten the structure. Instead of nesting asynchronous functions, you define separate named functions and pass them as callbacks. Promises. Promises provide a more manageable alternative to callbacks. A promise represents an operation that hasn't completed yet, but is expected in the future. Promises have three states: pending, fulfilled, and rejected. Replacing callbacks with promises. Promises help avoid the complexity of nested callbacks. By returning promises from functions, you can chain asynchronous operations more straightforward using the .then method for resolve promises and .catch for errors. Consuming promises. Consuming promises involves using the .then method to handle resolve values and .catch to handle errors. This approach results in a more readable and maintainable codebase. Creating settled promises. JavaScript provides promise.resolve and promise.reject methods to create promises that are already settled, either fulfilled or rejected. This is particularly useful in testing scenarios. Running promises in parallel. Using promise.all, multiple promises can be executed in parallel, and you can perform an action when all of them are resolved. If any promise is rejected, the entire promise.all is rejected. Async and Await. Async and Await keywords provide a way to write asynchronous code that looks synchronous. Functions declared with async return a promise, and await pauses the execution of the function until the promise is resolved or rejected, making the code easier to read and maintain. Error handling is done using try and catch blocks. By understanding and applying these patterns, you can effectively manage asynchronous operations in JavaScript, leading to more efficient and maintainable code.